All right, now we're ready to explore our first end-to-end project, and this is going to be an ingestion pipeline from Kafka events into an object storage. All right, so we're going to work with a real-world e-commerce streaming pipeline simulation. We're going to use fake data that are going to produce using the Faker library. Then the goal will be to demonstrate like the complete data journey from the generation to the first layer of storage of an analytical pipeline. All right. In this project, we're going to integrate Kafka, schema registry, and object storage. And we're trying to get very close to something that we might expect in a realistic scenario. All right. So we'll have an event generator that we're going to use the faker as I mentioned, and we're going to use the Avro serialization and deserialization. All right, we're going to send messages and events to schema registry. So at this point, we're going to have a schema validation at the entry point. Okay, our data is going to be uh, distributed across three brokers. So now we're going to use our multi-broker Docker Compose file, and they're going to be replicated across the three brokers as well. So we'll have the broker 1, broker 2, and broker 3 with a topic that are going to name shop stream purchases. That's the name of our company. And from that topic, we're going to process these values in a right now just a single consumer group, and we're going to do some kind of batching per region. You're going to see that our events are like regional based, and after that we're going to optimize the way those files are generated. We're going to transform them into Parquet to get an analytics optimized storage, and then we save to mini.io, which is going to be our object storage for now. Okay, so we produce events, do all of the validation and transformation, register the schema into schema registry. We're going to save it to all of our brokers inside our Kafka clusters. We read from our consumer, process these values to transform to generate Parquet files and save into the object storage. Okay, so this is what we're going to have inside our Docker network. So we're going to have our Kafka clusters with our three brokers here, Kafka 1, Kafka 2, and Kafka 3. That is going to be on three different ports. And we're also going to have our Kafka UI, just like we've been doing so far, the schema registry, and also now we're going to add in this mini.io service component we're going to use to access our object storage. All right. And here, this is a little bit more detailed details on what we're going to do. On the event generation, you see that we're going to have like user IDs and a region assigned to that specific event. We're going to have US, EU, and Asia. So we're going to have three regions to generate those purchase events. And our key for the message is going to be the user ID, so we can apply our ordering guarantees. All right. We're going to have Avro serialization with the schema registry validation, and we're going to use the faker library. All right. The Kafka partitioning is going to be the default based on that user ID. So the coefficient around the user ID will create a hash, and it's going to determine which will be the partition assignment. So at the end, we'll have all regions that are going to be mixed across all of the three partitions. So the same user always goes to the same partition, and we're going to have the replication factor equals to 3, so it can guarantee that we have the message applied and saved to every broker. All right. Now, when we're processing these messages, we're going to have just a single consumer group that is going to read from all of those partitions, and the events are going to be reorganized by the region field in the message that we have. Okay, so we're going to separate batches that are going to deal with them in memory based on the region, US, EU, and Asia. And once we finish this processing, we're going to manually commit this offset after we're able to storage them. And we're doing this because we want a specific data lake structure uh, based on a partitioning for the data lake now, not for Kafka, related to the region. So we'll have a organization in our object storage bucket that will be like the region is going to be US, the date. So we're going to have this business logic grouping for each one of the Parquet files uh, that we're creating. Okay, so this is going to be on our bronze layer in MiniIO. And before, of course, saving this information here, we'll need to do all of the transformation that we need to get the event transformed into a Parquet file that is very optimal for analytics since it's a columnar storage. We're going to talk a little bit more when we get to that video. Efficient compression, and we're going to process everything in memory. So in summary, we receive everything replicated in the buckets. We have the default Kafka partition strategy, but when we're consuming this, we're going to organize it into different batches that are going to be applied to the specific region, so we can save each Parquet file that pertains to a region into a specific bucket in the object storage. So I'm very excited to guide you guys through this. So I hope you enjoy and just follow the GitHub code and also the videos, and you'll be able to access also all of this documentation visually and textual. So you can always refer back to this if you have any questions.